Welcome to video 5.5b, a proof using quadrilateral properties. So here's example 1. I'll mark up the diagram as I go over the given. ABCD is a parallelogram, okay? Angle GHA, that's that angle, is congruent to angle FEC, that's that angle. HB is congruent to DE. Prove that GH, let's see if I can use green here. Prove that GH is congruent to EF. Okay, so without even batting an eye, it looks like if I can somehow get those triangles to be congruent, I can then get the corresponding parts to be congruent. So I'm going back to chapter 3 again. Okay, now I'm going to come up with a plan for getting those triangles congruent. Well, I've already got an angle inside. They gave me this side with this side. I know if I'm a parallelogram, opposite sides are congruent, so I will end up being able to get these sides congruent. I also know if I'm a parallelogram, opposite sides are parallel, and that if I'm cut by a transversal, I'll have alternate interior angles being congruent. So somehow, some way, I'm going to be able to get that angle to that angle. I'm going to be able to get that side to that side. So I'm thinking of angle, side, angle, ASA. So now I have a game plan. Now and only now do I start writing down the proof. And again, I'm going to go in ASA order. So I guess I could start with those angles that were provided. So I could say angle GHA is congruent to angle FEC given. Okay, then what I want to do is get the sides. So again, what I'm going to do is say that I'm a parallelogram. So ABCD is a parallelogram given. And then from that, I'm going to be able to get these opposite sides being congruent. So I can say DC is congruent to AB. And I'll say, if parallelogram, then opposite sides congruent. If, I'll just do this. If parallelogram, then opposite sides are congruent. Okay, then my given, that was over here, HB is congruent to DE, that was given. Now I could do segment subtraction. If congruent sides are subtracted from congruent sides, then their differences will be congruent. So I can now state that AH is congruent to CE by segment subtraction. Okay, so now I've got the side. Then I'm going to go for the angles. So I've already got that I'm a parallelogram, so now I can state that I've got parallel lines. So I can say line DC is parallel to line AB, and again that stems from this thing right here. If parallelogram, then opposite sides are parallel. Okay, and then once I've got those parallel with this transversal, then I can get these alternate interior angles. They're on the inside and alternate sides of that transversal. So I'll say angle GAH is congruent to angle, I'll call it FCE. And I'll say if parallel, then alt interior angles congruent. Okay, so that was the other angle. So now I've got triangles, and I got parts. I'll just label the triangles in the same way here. So I'll go triangle GAH is congruent. I gotta be careful. G to A, that would be F to C, so I was correct. Triangle FCE by angle side angle. And then let's see if I can get the parts. So I've got first and last. So first and last, that makes sense with the ordering. So segment GH is congruent to segment EF by CPCTC. Whew. So there you have it, how to do a proof using quadrilateral properties.